Welcome back, students. So we have discussed the introduction of 8051 microcontroller. So in this topic we will discuss about the IO ports of 8051 microcontroller. Generally IO ports in the sense, what are all the configurations? We have discussed about 4 ports, right? Port 0, port 1, port 2 and port 3. So these configurations, how these are configured, so that is the thing which we are going to discuss today. So we will consider first the port 0 configuration over here. So whatever may be the configuration, we have to consider the 3 main things. One is D latch, 2 tri-state buffer, so and another one is the transistor, which is nothing but here this is the transistor. So these 3 are the main components which will be used for all the configurations. Here we are using D latch, this is called as the D latch. In this why we are using this in the sense, this latch is used for each and every port. Initially when you are initializing the ports, it will be in the output mode. So if you want to move that to the input mode, you have to write 1 to this latch, okay. Only then it can act upon in the input mode. So all ports can be acted in either input or output or both input output. So if you want to choose that mode, if you want to choose the input mode, you have to put it into, you have to write 1 to that corresponding latch. So each and every individual latch will be connected with the ports. And these 2 are the buffers, that is 2 tri-state buffers. So here we are having 2 pins, one is read pin and the another one is the read latch pin. In this, okay, if this read pin is equal to 1, if this read pin is equal to 1, then your first buffer will start to read the data at that particular pin, from that particular pin, okay. And if this read latch is equal to 1, if read latch is equal to 1, then your buffer the buffer 2 starts to read the data present at the internal latch. Clear? So that is the purpose of these 2 buffers which is present over here, and we are having one transistor which is accommodated over here. This transistor is used as a gate. If this gate value is equal to 0, then automatically it will act as a open circuit condition. If this gate value is 1, then it will act as a closed circuit condition, okay. So for that purpose we are using this M1 as a transistor over here. The main importance of this port 0 configuration is, here we do not have the pull up resistor internally, we have to add 10 kilo ohm of resistor as a 10 kilo ohm resistor as a pull up resistors over here, okay. So why we are going for that pull up resistor, in the sense, what is the purpose of using pull up resistor? In the sense, generally when we are using these input pins, some input pins will be not in use over here, okay. So those pins have to be connected to the supply, and this process will be held by this resistors, pull up resistors. So unused input pins will be connected to the supply, and it will maintain the voltage at high level in the entire process, okay. So it will not move on to the any downstage or something like that. So that for this pull up resistor is used to keep the unused pins at always high levels in the entire process, okay. Next, coming to the P1 configuration, the difference between your port 0 and port 1 configuration is, it contains the load over here, not pull up resistor, it consists of load over here for the same purpose which is held by the pull up resistors, okay. Here also, but the same as like the previous configuration, you are having D latch, okay. As I told you already, your ports will be in the output condition. If you want to move it to the input mode, then you have to write 1 into that particular latch, and we are using 2 buffers, TB1 and TB2 over here. Your TB1 buffer will be controlled by the read pin, and TB2 will be controlled by the read latch pin as in the port 0 configuration. If this read pin is equal to 1, then automatically your buffer 1 will start to read the contents of contents which is present in the read pin. And If this read latch is equal to 1, then your buffer 2 starts to read the contents at that particular internal latch, okay, and M1 will act as a, that is M1 is nothing but the transistor will act as a gate over here. And then coming to the port 2 configuration, the difference between your port 2 and port 0 configuration is, here you are using the internal pull up resistor over here. It is not necessary to add pull up resistors. So, that is the only difference which is accommodated over here. So, other than that, everything as like the previous cases, you are using the D latch and 2 buffers and transistors, 1 transistor, okay, and if you write 1 to this D latch, it will be act upon in the input mode. Your port 2 configuration will be act upon in the input mode. And I told you that these port 2 is used for higher order address bus signals. This port 2 is used for higher order address bus signals. So, that is what A8 to A15 has to be accommodated with port 2 configuration, okay. Then coming to the port 3 configuration, the same concept as like you have seen in that port 0, port 1, port 2, here also you are having that D latch and 2 buffers over here, a transistor which is acting as a gate and internal pull up resistors, but the one difference what is that is present, what is the difference which you have find out over here in the sense, you can alternate the input function as well as output function which is accommodate over here, okay. You can alternate the input function as well as output function which is present in this, which is coming up into this circuit, okay. That is the function of your port 3 configuration. I told you that your port 3 pin will consist of some hardware parts of signals, hardware signals like receiver signal, transmitter signal which is nothing but the which is coming from the serial ports, and interrupt pin. These INT 0 and INT 1 is nothing but the interrupt pins which is coming from the external interrupts, and T0 and T1 is nothing but the timer signals which is coming from the timer 0 and timer 1 over here, and the WR and RD is nothing but the write and read pin if you want to write or read anything from externally. So, these pins are used for port, that is these signals, all these signals are used in the port 3 configuration, okay. So, in the next session we will discuss about the CPU registers, where you will find out what is the meaning of register, what are all the types of register, and how we are going to organize all these registers. Thank you. Welcome students. In this session we are going to discuss about the CPU registers. Here what is the meaning of register actually? Why we are going for registers? Yes, register is nothing but the storage device where we can store the data temporarily, okay. So, there are several types of registers in that. One is A and B register. So, there are several types of register in that. One is A and B register, data pointer register, program counter, stack pointer register, program status word register, and special function registers. So, we will see each and every, we will see clearly about each and every registers over here. So, first let I explain what is the meaning of A and B registers. Here A register is nothing but the accumulator, where it is represented as A in all programs, okay. And wherever you are performing arithmetic operations or any logical operations, or you want to move any data from one processor to any other devices, so at that kind of cases we are using the accumulator as a register over here. And B register is nothing but it will be used along with the A register, okay. For example, while you are using the multiplication function, that is MUL, okay. So, at this place you are using that A B, okay. So, if you are giving this command, it shows you that MULAB in the sense the contents of B and contents of A will be multiplied and it again stored in the A register, okay. So, along with the A register, your B register will be used over here. So, each and every register consists of 8 bits from R0 to R7, so as it is shown over here. And the next one is the data pointer register. data pointer register is generally a 16-bit register. It is divided into two 8-bit registers like data pointer high and data pointer low. Okay, this entire 16-bit register is not used as it is. It will be divided into two set of registers. One is data pointer high and data pointer low. Clear? Here generally where we are using this data pointer cases, in the sense when we are going to access the external memory, at that time we are using the data pointer. Like for example, if you are giving the command move x at dptr comma a, then it shows you that the contents of a will be moved on to the dptr. Okay, this move x corresponds to there is the data transfer between the accumulator and the external memory. So that's what it corresponds to, move x. Okay, so this is how your data pointer register will work over here. Clear? And the next, coming to the program counter, here program counter is also a 16-bit register, where your program counter will not be it will be used as it is as the 16-bit register. There is no any division of it. Program counter in the sense, whenever we are we can process many instructions, right? So whenever there is a fetching of instruction, that particular address has to be stored. So this program counter is used to store the address of the next instruction that has been fetched. Okay, and for example, if this is the 16-bit here we are using the 16-bit register, it is, right? So it starts from 0000H to it ends at FFH. So whenever you are going to add one new instructions, the address of that particular instruction will be loaded into the program counter. If it starts from 0000, so the address of the next instruction will be stored in 0001H. Okay, and the address of the another instruction will be stored in 0010H. So this is the flow of the instructions entirely. Clear? The next, coming to the stack pointer. Here stack pointer generally it holds the addresses of your internal RAM. Okay, how it holds, in the sense, it generally it takes the values of 00H to FFH over here. So it starts from the 07H. While you are initializing the 8051 microcontroller, your stack pointer will start from the 07H. That is, it shows that the first 8 RAM locations, that is 8th RAM location, will be used as the stack pointer. Only the 08 is the first RAM location where your stack has been used over here. Okay, it consists of two operations. One is push operation as well as pop operation. Pushing in the sense, whenever your CPU wants to store the data, whenever your CPU wants to store the data into the stack pointer. Okay, that is called as a pushing operation. Pop in the sense, whenever CPU retrieves data from the stack pointer. Okay, so these two are the operations which is done by the stack pointer. Pushing in the sense, your central processor will store the data into the stack pointer, and if it is pop operation, your CPU will retrieve the stack pointer, retrieve the data from the stack pointer. Okay, then coming to the program status word. Program status word in the sense, it contains the current status of your processor. Okay, for example, I will tell you how it is. It is a 8-bit register actually. Your program status word is a 8-bit register. It starts from D0 to D7 bit. So your D0 bit consists of P, which is nothing but parity bit. Parity bit, this P is nothing but parity bit, where you have two options. One is, it can be either 1 or 0. right? If this parity bit is 1, it shows that it is the odd parity bit, and if this parity bit is 0, it tells you that it is the even parity bit, okay? And next D1, bit number D1 is unused bit, it is fixed for the future purposes, and D2 is nothing but the overflow bit. Overflow bit in the sense OV is nothing but overflow bit. Overflow in the sense, if this bit is equal to 1, then it shows that your overflow bit has been set, okay? If this bit is equal to 0, then it shows that your overflow has not set. What is the meaning of overflow? Generally, I told you that it is the it consists of 16 bits, right? So if it starts from 0000H, then it has to ends at FFH. Clear? So if it moves on to the 40H, then it is said to be the overflow bit. Then your overflow bit will set over here, okay? And these two bits, RS1 and RS0, is nothing but the register bank select bit, okay? So we will this is nothing but register bank select bit. So we will discuss about these two bits in detail in the next session. I will tell you what is that, where we are using that, everything. And this F0 is nothing but the user flag. F0 is nothing but the user flag bit, and this AC is nothing but the auxiliary carry bit. Bit number 6 is the auxiliary carry bit. Whenever you are using the specialized arithmetic operations, at that time you are using the auxiliary carry bit over here. And this one is the carry bit, general carry bit. Whenever you are performing the arithmetic operations, so at that time if carry occurs, it will tell you it is this bit will set to 1. If not, this bit will set to 0. So generally, why we are using this program status word register? In order to know the current status of your processor, we are using this program status word register. Clear? Then coming to the special function registers. In the special function register, these are all nothing but addresses. From 80 to F8 will tell you the address at which place your registers have been specified over there, okay? So this B register, accumulator, program status word, everything, they are all the basic registers which we have discussed. Your special function registers will start from interrupt priority and it ends at power control register, okay? So what are all the abbreviations I have just given over here? IP is nothing but interrupt priority register. That is, I told you that we have two external inputs, right? So as per external interrupts, sorry. So as per the priority of that interrupt, it has to be processed. So for that we are using this interrupt priority bit, and this is interrupt enable bit. Interrupt enable bit. If your bit, if interrupt has to be processed, that bit has to be enabled. So only then it can be processed, right? So that one is the interrupt enable bit. And the next one is SCON, which is nothing but serial control register. Serial control register, and SBUF is nothing but serial buffer register, and we will study about these two registers in detail in the serial communication interface where we will discuss in the upcoming sessions. And this TCON is nothing but the timer control register, and this TMOD is nothing but the timer mode register. And these two registers will be discussed in the timer and timer bar counter session, where we will going to discuss in the upcoming sessions. So these two registers will be discussed in detail over there. And this is nothing but stack pointer we have seen just now, and DPH and DPL is nothing but the data pointer high and data pointer low. As I told you that your entire 16-bit data pointer register will not be used as it is. It will be divided into two 8-bit registers. One is data pointer high and another one is data pointer low, okay? And coming to the quiz, these are the questions which I have set for you for this session. Kindly note down it and try to find the answers of it and come up with the answers in the next session. So in the next class we are going to discuss about the 8051 memory organization. That is, in that what is the meaning of in that class we will discuss about what is the meaning of memory, what are the types of memory, and what are the advantage, how these memory has been organized over there. So that are all the concepts which we are going to discuss in the next session. Thank you.